Hi math friends, today we're looking at writing equations from a table of values. This can be kind of tricky and it is always going to be useful for us going forward here too. So let's check out this table here. So we're comparing the stack height of containers to the number of containers that are here. So when you have like Tupperware containers and you're stacking them and putting them inside each other. So one starts out really tall, but then you only have that tiny little lip that like goes on top to stack them in. So that's what we're doing here. So when I look at a table like this, first thing I want to do is look for patterns, right? So are there any patterns here that we notice? Well, let's see how this goes. So number of containers keeps increasing by 1. All right, so when we see this, this is a good sign for us. This keeps increasing by 1. All right, so if I do find a pattern here with the height, then we can just keep on going with our pattern. So 14, 14.3, 14.6, 14.9. Looks like it's going up by 3/10 or by 0.3 every time here. So if we add on another 0.3, I'm going to have 15.2, 15.5, 15.8, and so on. Always a good idea to do this if we can. Usually there's questions afterwards or a graph to do, and this will help us with all of that. All right, so we keep adding 0.3, 15.2, add 0.3 more, and so on. All right, let's check out the circle one. So the circle is, first one is 5, and then we go 5.7, and then 6.4, and then 7.1. Looks like we're adding 0.7 every time. So another 0.7 would be 7.8. Add it again, we're going to have 8.7. Add 0.7 again. All right, we're going to have 8.5. Add 0.7 again, we're going to have 9.2. 9.9. 10.6 or 10 6/10 if you prefer that. Then we get 11.3. So this time we just kept adding 0.7 or 7/10. All right. So important to know that. And I usually like to, in my table here, write that down here plus 0.7, and over here, so it's a plus 0.3. Knowing that pattern, that rate of change is going to really help us. And also look, one container, this is where we start at for these. That's going to help us as well. All right, so let's remember those numbers, and we'll flip back to this if we need to. All right, so look at the square. The square starts at 14, and it changes by 0.3. So we're going to write that down for ourselves. So the square starts at one container is 14 centimeters, changes by plus 0.3 per container added. All right, I'm just going to double check that again. All right, and the next one's 5 and 0.7. So the circle starts at one container is 5 centimeters, changes by plus 0.7. Now, when we're stacking things, we usually just add, but there are going to be some situations with different tables and different equations where you do subtract. So that's why I'm being very careful to write 0.7 per container. All right, so now we're going to use that to write an equation. So this is all the information that we need to be able to write an equation to calculate the total height. So here we're going to let the height be h, and we're going to let the containers be the variable c. So the total height depends on how many containers we have. So height, let me use a different color here too. Height equals, and look at what we started with. We started with 14 for the square containers plus 0.3 each time. And when I think of each, I think of multiplying, right? So we're going to multiply by c, but we actually have to remove the first one. So I actually need parentheses here too. All right, so this is what's a little confusing to think about. We know the first one is 14, so whenever I want to find the total height here, I have to subtract that first one, and I'm going to do that right away. Like the total height for two of them, I'm going to do 2 in for C, 2 minus 1. I'll do that first before I multiply. All right, for the other one, it started at 5, and it changed by 0.7 as we kept adding them. And same idea here. We need to do C minus 1 to help remove that first one again. All right, so sometimes we need to think about the situations logically, but we can always do this for whatever number we start with. We started with 1, so we're doing C minus 1. We started with one container. All right, we're going to take these equations, and let's just look at them both again. I'm going to type them in here together. And there's a lot of things that we can get from these equations. And depending what grade level, what level of math we're doing with this, we might be asked a lot of different things. Like we see that they both have H, they both have C minus 1. So they're within the same situation of trying to find a total height for any number of containers. All right. So we have the square ones and the round ones, and we can find a lot of good information here. We could even say we start at 14 for the first one. We start at 5 for the first one. So that's a little bit different. And we change by adding 0.3 centimeters. This one changes by adding 0.7 centimeters. So just by looking at these equations and knowing what those numbers mean, we can get a lot of information from this. All right, and remember, use this video lesson as a guide as you're doing these two. We can actually simplify them, so we're going to go ahead and copy that and put them here. So remember that when we simplify, we're going to create equivalent equations. All right, so let's actually look at these side by side. And let's try to create equivalent equations here. So I'll go ahead and make that a little bit smaller so it'll fit. When you simplify these, and you don't need to, you could actually get all the information you need as they are, but sometimes we're looking for equivalencies or just a different form of the equation. So remember to distribute. So we get 0.3c minus 0.3. And this 14 is still kind of hanging out here, right? And so is the equal sign, and so is the h. All right, so now just one more step. So 14 minus 0.3, I get 13.7 plus 0.3c. Now, depending where we are, we might want to write it in slope-intercept form. You could leave it like that. Slope-intercept form, your y equals mx plus b will be like this. If you're watching this lesson and you're not on that yet, that's okay. But that's just a different way to write it. And it's really important to remember, guys, right? This equation that we started with is the same as this. Okay, we distributed, we combined like terms. They're equivalent. They're going to be the same thing. If we plot these, they're the same exact line. They just look a little different. All right, let's try the same thing with the next one too. So distribute. So I'm going to have h equals 5 plus 0.7c minus 0.7. All right, so combine our like terms, right? 5 minus 0.7, so I'm going to get 4.3 plus 0.7c. And usually we'll want it in this kind of form, this slope-intercept form. And we usually write the variable first, so 0.7c plus 4.3. Again, you don't have to. But look, we've created an equivalency. You can plot these or use the information with either that you want to. So both of these in pink, they're the same thing. Both of these in purple, they're the same thing. Okay, it's important to know how to manipulate equations because sometimes some are easier in different forms than others. All right, Hope that was good for us, and we'll see you next time. Take care, math friends.